In the deep silence of the universe, far beyond the rivers of light we call galaxies, there drifts a ghost. It is not a galaxy as we know them, not a whirl of starlight, nor a furnace of creation, but the husk of what once was, a relic, a skeleton dot, where once billions of stars were born in waves of brilliance. Only silence now remains. The dust of ancient suns has settled into stillness. The rivers of cold gas that once ignited new generations of stars have evaporated into emptiness. What remains is the faint afterglow of a structure stripped of its lifeblood. A collapsed galaxy, hollow and quiet, suspended in the dark. Its bones are written not in calcium or marrow, but in arcs of dead stars, in the skeletal lattice of dark matter that holds its shape against the endless pull of nothingness. Around it, space is vast, unfeeling. No more light will come. The echo of its life has ended. Astronomers call them quenched galaxies, but the word barely holds their weight. They are the grave markers of cosmic time, luminous once extinguished now. And they whisper a terrible question. If galaxies can die, then nothing in the universe is eternal. What force snuffs out these colossal cities of stars? Is death woven into the very fabric of cosmic evolution, as inevitable as entropy itself? Or do these skeletons carry a deeper secret, a hidden key to the fate that awaits not only galaxies, but the universe entire? The story of a collapsed galaxy is not only about its death, it is about ours. For most of human history, the night sky seemed eternal, a dome of stars, steady and unchanging, a backdrop for myth and story rather than a living, breathing cosmos. The ancients believed the heavens were fixed, an eternal order of lights. To them, galaxies, if noticed at all, were faint smudges, whispers at the edge of human sight. The Andromeda galaxy, visible as a ghostly blur in dark skies, was catalogued not as another world, but as a nebula, a cloud of unknown light. The universe seemed singular. The Milky Way was everything, but in the early 20th century, a quiet revolution began. In 1924, Edwin Hubble, gazing through the Hooker telescope at Mount Wilson Observatory, looked upon the Andromeda Nebula with suspicion. By studying Cepheid variable stars, stars that pulsed in brightness with predictable rhythms, he measured their distances, and what he found shattered humanity's place in the cosmos. Andromeda was not a nearby cloud of gas. It was an entire galaxy, an island universe, millions of light years away, filled with its own stars, its own suns, its own mysteries. The universe was suddenly vast, no longer a single Milky Way, but a cosmos filled with countless galaxies, each a city of billions of stars. This discovery altered the human story forever, and with it came the first realization: if galaxies can be born, then perhaps galaxies can also die. In the decades that followed, astronomers turned their instruments skyward, hunting for patterns in the light of distant galaxies. They began to see diversity where once they imagined uniformity: spirals, elliptical, giants, irregular fragments. Galaxies were not static jewels. They were dynamic, changing, evolving across billions of years. But among the vibrant spirals filled with gas and dust, galaxies still alive with the birth cries of stars, another kind began to appear, luminous but silent, red in color, swollen and ancient. Unlike spirals, they did not sparkle with newborn stars scattered across their arms. Instead, their light was dominated by old, dying suns. They became known as red and dead galaxies. It was a phrase at once simple and haunting. These galaxies, massive and ancient, seemed stripped of vitality. Their stellar nurseries had been extinguished. No new stars were forming. Their spiral arms, if they had once existed, were gone, smoothed into featureless ellipses. They stood as graveyards of stellar life, immense reminders that the cosmos is not only a place of birth, but also of silence and decay. Through the mid to late 20th century, the suspicion grew. Using larger telescopes and more sophisticated instruments, astronomers began cataloguing galaxies by the thousands. Patterns emerged. Star-forming galaxies were blue, alive with young hot stars. Dead galaxies, meanwhile, glowed red, their light dimmed and cooled by the dawn of the 21st century. With the launch of large surveys like the Sloan Digital Sky Survey, the mystery became impossible to ignore. Mapping millions of galaxies across the universe, astronomers discovered a striking divide, a galactic color magnitude diagram known as the Green Valley. On one side, galaxies bursting with life, colored blue. On the other, silent galaxies, red and quenched. In between lay the transition, the valley through which galaxies must pass as they lose the ability to form stars. The universe, it seemed, was filled not just with creation, but with extinction. The Hubble Space Telescope, peering into deep time, revealed ghostly shapes from billions of years ago. Galaxies caught mid-collapse, their star-forming gas stripped away, their lights fading. Some had died astonishingly early, just a few billion years after the Big Bang. Too soon, too sudden. Their skeletons haunted the cosmic record like fossils, preserved in light that traveled billions of years to reach us. Each new discovery carried the same chilling implication. Galaxies are mortal. They can thrive for billions of years, but in time they wither. Their bones remain vast ellipticals and collapsed remnants, drifting across the dark ocean of space. Yet the mystery deepened. For what was killing them? The universe is filled with hydrogen, the raw material for stars. In principle, galaxies should be able to recycle their gas endlessly, birthing new generations of suns. Supernova return elements to space, nebulae collapse into new stars, and the cycle continues. If the cosmos is so abundant, why should a galaxy ever die? The discovery of galactic death shook the scientific imagination. To observe a dead galaxy was to confront a contradiction, a silence where there should have been music, like stumbling upon a forest where every tree had stopped growing, yet the soil remained rich. Something unseen was smothering them. Collapsing clusters told part of the story. As galaxies drifted into dense environments, their gas could be stripped away by the heat and pressure of intergalactic plasma. In these crowded regions, galaxies suffocated, stripped to their skeletons. Astronomers began to use the term ramp stripping, the violent tearing away of a galaxy's gas as it plunged through the hot medium of a cluster. But this was not the whole answer. Many galaxies died in solitude, far from clusters, their skeletons drifting alone in the dark. Something else, something internal, was extinguishing them. The Sloan Survey, the Hubble telescope, and later instruments revealed a cosmic symmetry on every scale. Not just solitary galaxies, but collapsed clusters, once vibrant ecosystems of star-forming galaxies, now reduced to dim relics. Stellar graveyards where neutron stars and black holes outnumbered the glowing suns. The discovery phase thus unfolded, not as a single revelation, but as a growing recognition. Step by step, image by image, the cosmos whispered its truth. Galaxies are not forever. They are born in the fire of cosmic dawn, but they also die, leaving behind the skeletal remains. Of their grandeur, the realization carried with it both wonder and unease. Humanity had barely learned that other galaxies existed, only to discover that many of them were already dead. It was as if a child, having just learned of the existence of forests, suddenly found them filled with fallen trees. In these discoveries, the mystery of galactic death emerged, not a curiosity at the edges of astronomy, but a profound question about the nature of cosmic life itself. The skeleton of a collapsed galaxy became not just an image, but a symbol, a reminder that even the greatest structures in the universe carry within them the seeds of their own extinction. And so the stage was set for a new kind of investigation, to ask not only when galaxies die, but how, not only what is lost in their collapse, but what truths their skeletons might whisper about the destiny of all things. For centuries, the night sky had seemed immortal. Stars blazed, constellations endured, and galaxies once discovered appeared as permanent structures woven into the fabric of eternity. The very idea of galactic death felt inconceivable. A galaxy, with its hundreds of billions of suns, its dust-laden rivers, and its dark matter skeleton, seemed far too colossal to ever truly fall silent, and yet the evidence could no longer be denied. When astronomers first began to realize that galaxies could stop forming stars, it seemed as though the universe itself had betrayed a promise. Galaxies were not perpetual engines of creation. They were fragile, mortal, and in their death, they revealed something terrifying. The laws of nature that give rise to light also allow it to fade. The shock was not merely observational, but philosophical. A galaxy ought to recycle. Supernova should replenish gas clouds. Gravity should compress those clouds into new suns. Stellar death should fuel stellar birth, an endless cosmic rhythm. Yet in some galaxies, that cycle ended abruptly, leaving behind only aging stars drifting toward darkness. The silence was unnatural, a violation of expectation. It was as if a city had gone quiet, its factories abandoned while its streets still stood. The structures remained, but the pulse of life had vanished. Scientists gave them clinical names: quenched galaxies, ellipticals. But behind those names was a haunting truth. Galaxies could die not slowly, but violently, catastrophically, as though strangled by forces still unseen. The most shocking revelation was temporal. Many of these skeletons were ancient. Some galaxies, observed through the time machine of telescopes, appeared to have collapsed only 2 or 3 billion years after the Big Bang. They had died young, in what should have been their age of flourishing. The cosmic dawn, once thought of as an age of beginnings, was now seen as an age where endings also occurred. How could galaxies die so soon? The laws of astrophysics provided no simple answer. Hydrogen was plentiful, gravity was relentless, energy was abundant, and yet the deaths were undeniable. Light from billions of years ago carried the fossil record of their silence. Red and dead galaxies stood as proof that something beyond the expected rhythm of birth and death was at work. The shock echoed across cosmology. The realization that galaxies could wither posed questions about the stability of the universe itself. If entire galaxies could collapse into skeletal remnants, was any structure permanent? Could even clusters, superclusters, or the great web of galaxies that laced the cosmos one day dissolve into silence? At the center of this growing unease was the question of power. What could possibly smother an entire galaxy, cutting off its Star formation, as though flipping a switch. Speculation turned toward the monstrous engines at galactic cores, supermassive black holes. These invisible giants, millions or billions of times more massive than the Sun, were known to anchor galaxies. Their gravitational pull shaped the motions of stars. Their energy outbursts could blaze brighter than the combined starlight of entire galaxies. Could it be that the very heart of a galaxy was also its executioner? Could the central black hole, in a paradox of creation and destruction, both anchor and extinguish its host? Others pointed toward environment, in the crowded halls of galaxy. Clusters, the surrounding plasma reached temperatures of millions of degrees. As galaxies plunged through this medium, their gas could be stripped away, their lungs torn from them by ram pressure. In this view, death was not self-inflicted, but forced by a brutal cosmic environment. Neither explanation was fully sufficient. Some galaxies died in isolation, far from clusters. Some seemed too massive to be choked by internal black hole feedback alone. The answers did not fit neatly, and therein lay the deepest shock of all. Not only that galaxies die, but that the mechanism of their death remains a mystery. The scientific community was unsettled. In every direction they looked, the skeletons of galaxies appeared. The cosmos seemed littered with them, reminders that creation's brilliance was always accompanied by decay. The great cosmic balance between star birth and star death was not guaranteed. It could fail, and when it did, the result was irreversible silence. For ordinary matter, this was devastating. Gas clouds that should have collapsed into suns were heated, expelled, or locked away. Elements that could have formed planets, atmospheres, even life, were trapped in sterile reservoirs. A dead galaxy was not just a loss of stars, it was a loss of futures. Entire generations of possible worlds extinguished before they were born. The philosophical weight was inescapable. Humanity's home galaxy, the Milky Way, still breathes with star formation. It spins with young clusters, nebulae glowing with stellar birth. But the presence of skeletal galaxies scattered across the universe is a warning. If they can die, so can we. If galaxies can collapse into silence, then no cosmic city of stars is eternal. The laws of physics had seemed stable, predictable, but these discoveries fractured that sense of permanence. They hinted at forces far more ruthless than previously imagined forces that do not simply govern the universe, but extinguish its lights. It was in this recognition that the true shock lay. Galaxies are not timeless. They are fragile structures, balanced precariously between creation and annihilation, and their deaths are not distant curiosities. They are omens, written across the dark, of the fate that may await all things. The skeleton of a collapsed galaxy became more than a scientific object, it became a memento mori for the cosmos, a reminder that the universe is not only a cradle of light, but also a cemetery of silence. Once the shock had settled, the work of science demanded precision. To witness the skeleton of a galaxy was one thing. To understand it required the language of data, the careful dissection of light, the relentless pursuit of hidden patterns. If galaxies could die, then astronomy had to ask, how and under what laws of physics does such a death unfold? The first tool was spectroscopy. When light from a galaxy is split into its component wavelengths, it becomes more than radiance. It becomes testimony. Every dip and spike in that spectrum carries the fingerprints of stars and gas, from the faintest shifts in hydrogen lines. Astronomers could deduce whether gas clouds were collapsing to form stars, or whether silence had taken hold. It was here that the term quenched galaxies gained its precision. Their spectra told the story of lost youth. No bright ultraviolet signatures of young, massive stars. No restless hydrogen clouds birthing suns. Instead, only the mellow glow of old stars, red and cooling, carried across billions of years of distance. These spectra were fossil records, proof that galaxies could stop creating, leaving behind only the echoes of what had once burned bright. But spectroscopy alone was not enough. To understand death, one must look beyond the corpse to the invisible forces around it. So astronomers turned their gaze to X-rays. Through instruments like the Chandra X-ray Observatory, dead galaxies revealed halos of hot plasma, gas heated to millions of degrees, surrounding their skeletal forms. This gas, far too hot to collapse into stars, was locked in stasis. It was fuel, but fuel kept forever out of reach. Why did this gas remain sterile? Some pointed to the outbursts of central black holes. In active galaxies, supermassive black holes do not merely consume, they also erupt. Jets of energy, spanning thousands of light years, can heat surrounding gas until it can no longer cool and collapse. If galaxies are factories, then their central engines could become saboteurs, shutting down production forever. The evidence began to align. Galaxies with powerful central black holes often lacked star formation. The very heart that bound them was also the hand that silenced them. Yet, anomalies persisted. Some galaxies without powerful black holes still lay dead. Others, with active cores, still thrived. The skeletons resisted simple explanation. Gravitational lensing provided another window. By measuring the way light from background galaxies bent around foreground structures, astronomers mapped the dark matter scaffolding that gave galaxies their shape. These maps revealed that skeletal galaxies remained bound by massive halos of dark matter, unseen but undeniable. Even when the light of stars had faded, their invisible skeleton remained, a ghostly lattice that kept their bones intact. It was a paradox. A galaxy could die in every luminous sense, its stars aging without renewal, and yet its dark matter frame would persist, unbroken, across cosmic time. The bones endured even as the flesh vanished. Astronomers also studied galactic clusters, congregations of hundreds or thousands of galaxies bound together by gravity. Within these environments, death was common. Instruments detected streams of gas being stripped away as galaxies plunged through the dense plasma of the intracluster. Medium. Like animals drowned in a river to swift, galaxies lost their lifeblood to the pressure of their surroundings. Ram pressure, stripping, once a theory, became visible in long tendrils of gas torn from galaxies as they fell silent. Yet again, the puzzle deepened. Not all skeletons were born in clusters. Some galaxies lived and died alone, far from neighbors, their collapse unexplained by environmental violence. Isolation was no guarantee of survival. Death had many faces, and so astronomers expanded their search backward in time. With instruments like the Hubble Space Telescope, they peered deeper into cosmic history, capturing galaxies as they appeared. Billions of years ago, what they found unsettled them further. Some galaxies had already died in the universe's youth, when it was less than a quarter of its current age. These ancient skeletons suggested that whatever forces were at work, they could act swiftly, snuffing out galaxies long before their prime. The James Webb Space Telescope has begun to push this investigation even deeper. With its infrared eyes, it detects faint, quenched galaxies from the earliest epochs of the universe. Some are massive, already dead just a few 100 million years after the first stars were born. They defy the neat timelines of theory. How could such giants rise and fall so quickly when the cosmos itself was only beginning? Instruments on Earth, too, contribute. The Atacama Large Millimeter Array, perched in the thin air of the Chilean desert, traces the cold molecular gas within galaxies. Its findings often compound the mystery. Some galaxies retain reservoirs of gas enough to form billions of stars, and yet no stars are born. The ingredients remain, but the recipe is lost. Something prevents collapse, holding the galaxy in a state of eternal suspension. Simulations have tried to bridge these gaps. Supercomputers model galaxies across billions of years, tracking the interplay of gravity, radiation, black holes, and dark matter. These virtual universes show that feedback from supermassive black holes can indeed choke galaxies, halting star formation by heating gas beyond recovery. They show that clustered environments can strip galaxies bare, leaving skeletons behind. Yet even the most advanced simulations fail to account for every death. The real universe remains more chaotic, more merciless than models predict. The investigation thus evolves into layers of mystery. Each discovery solves one piece, only to reveal another. Why does hot gas remain sterile for billions of years? Why do some galaxies die isolated? Why do some die so young? The skeletons of collapsed galaxies refuse to yield a single story. They are not uniform deaths, but a spectrum of endings, some violent, some slow, some inexplicable. And so astronomers continue, pointing instruments skyward, reading spectra like autopsy reports, tracing arcs of light through gravitational lensing, modeling cosmic histories in silicon and code. The universe is a laboratory, and its graveyards are filled with clues. Each dead galaxy studied brings humanity closer to an understanding, and yet each also reminds us of our ignorance. For the skeleton of a galaxy is not merely a corpse. It is a riddle etched into the dark. The deeper the investigation goes, the clearer one truth becomes. Galaxies die, but the universe will not tell us easily why. Its silence is deliberate, its bones hidden in the shadows of time. And in chasing these remains, humanity confronts not only astrophysical puzzles, but the uncomfortable reflection of its own mortality. For the death of a galaxy is not just a scientific anomaly, it is the reminder that nothing, not even the grandest of structures, is beyond extinction. The deeper the investigation went, the darker the mystery became. At first, galactic death seemed a curiosity, an exception. But as more surveys stretched deeper into space, as more light was unraveled through lenses and mirrors, it became clear. Death was not rare, it was everywhere. The skeletons of galaxies haunted every epoch of the universe, scattered across billions of light years. And with each new discovery, the question sharpened. Why does the cosmos allow its brightest cities of stars to collapse so completely? What unsettled astronomers most was not only the frequency of galactic death, but the speed. Some galaxies were found to have collapsed mere billions of years after the Big Bang. These were not fragile dwarfs, but massive giants, extinguished at a time when the universe itself was still young. By all expectations, they should have been rich with gas, fertile with star formation. Yet their light betrayed the truth. They had already gone silent. The implications rippled across cosmology. If galaxies could die so early, then perhaps the very architecture of the universe carried within it a principle of collapse, a rule not of creation, but of silence. Death, it seemed, could strike not after long decay, but in sudden, irreversible plunges. This gave rise to visions of cosmic cannibalism. Across the sky, astronomers began to detect galaxies devouring one another, spirals colliding, disks torn to ribbons, stars flung into tidal streams stretching millions of light-years. When such mergers occurred, delicate structures were destroyed. The spiral arms dissolved. Gas was shocked and heated, unable to collapse into stars. The result, elliptical husks, stripped of their ability to renew themselves. A galaxy could be murdered not only from within, but by its kin through collision and consumption. The images were brutal. Two galaxies colliding, their shapes mangled, their cores merging into a monstrous whole. The aftermath was often silence, an elliptical giant, glowing red, starved of new light. Galactic skeletons could be forged through violence on the grandest scales, but cannibalism was only part of the horror. At the heart of many dead galaxies lurked a greater suspect: supermassive black holes. These central engines, already enigmatic, began to look less like anchors and more like predators. When they erupted with jets of energy streams, of plasma traveling near the speed of light, they carried enough power to sterilize entire galaxies. Gas that should have cooled was heated beyond recovery. Clouds that should have collapsed were blown into intergalactic space. The very mechanism that may once have fueled growth now became an executioner. Evidence piled up. Observations revealed that galaxies hosting the most massive black holes were disproportionately dead. Quenching and black hole feedback seemed tied. It was as if the heart of the galaxy, once its sustaining core, eventually grew too powerful, too destructive, and strangled its own host. Creation and annihilation fused into one, and yet anomalies persisted. Not every dead galaxy bore an active black hole. Some skeletons floated in silence, their cores seemingly quiet. If black holes were executioners, they were not the only ones. The mystery deepened into layers, overlapping causes that refused to resolve into a single truth. The cosmic web itself, the great network of filaments, made of dark matter and galaxies also, came under suspicion. This scaffolding, stretching across billions of light-years, is the skeleton of the universe itself. Galaxies form along its filaments, drawing gas from the intergalactic medium. But simulations suggested that galaxies at certain nodes of this web could be cut off, their supply lines severed. Deprived of new material, they starved, collapsing into silence. Galactic skeletons may not just be the result of internal processes, but of their position within the cosmic architecture. Here lay the most chilling escalation. The possibility that death was not accidental, but structural. That galaxies die because the universe itself dictates it. That the skeletons of collapsed galaxies are not merely accidents of violence or black hole rage, but necessary consequences of the very way matter organizes itself in space-time. The philosophical tremor was profound. If galaxies die young, if their collapse is written into the architecture of the universe, then what of the future? What if the great cosmic web is itself a skeleton in formation, an immense graveyard in slow construction? Already, surveys reveal that star formation across the universe is in decline. The cosmic noon, the peak era of star birth billions of years ago, has passed. Since then, light has been fading. One by one, galaxies quench. One by one, the universe grows quieter. The escalation was no longer confined to individual galaxies. It became a question of the cosmos itself. Could the entire universe one day resemble a skeleton of collapsed galaxies, each silent, each red and dead, stretched into an endless cemetery? Even now, evidence hints at this fate. In distant clusters, galaxies are stripped bare by tidal forces, leaving only faint streams of stars, ghosts trailing into the void. In the outskirts of the universe, some galaxies shine with only ancient light, their youth extinguished eons ago. Simulations predict that, in trillions of years, star formation will cease entirely. All galaxies will become skeletons. The night sky, once ablaze, will wither to embers. The escalation of this mystery is not only scientific, it is existential. For humanity lives in a spiral galaxy, still alive, still breathing stars into being. The Orion Nebula glows with new suns. Stellar nurseries sparkle across the Milky Way. But to look outward is to see our future written in others' remains. Every dead galaxy is a mirror, showing us not only what has been lost, but what awaits. The question is not if galaxies die. The question is when ours will dot. And with that realization, the mystery deepens further still. For galaxies are more than arrangements of stars. They are potential wombs of life, cradles of worlds, incubators of futures. To see them silenced is to see countless possible civilizations, countless possible histories extinguished before they could begin. Galactic skeletons are not merely astrophysical relics. They are cosmic tragedies written across scales far beyond imagination. The escalation, then, is total. What began as faint whispers of silence in red galaxies has become an all-encompassing vision of mortality, one that stretches from the heart of black holes to the very structure of the universe itself. Each discovery amplifies the fear that the cosmos is not eternal growth, but eternal decline, and so the mystery deepens, not with answers, but with shadows. The skeletons of collapsed galaxies stand as monuments, each one a reminder that creation is fragile, that light is temporary, and that silence is the truest ruler of time. The skeleton of a collapsed galaxy is more than a relic. It is a puzzle, a silent city of stars drifting across the dark, whispering of forces powerful enough to halt creation itself. What could extinguish such immense structures capable of birthing suns by the billions? What hidden physics smothers galaxies, turning them from brilliant spirals into husks of red and dead stars? The investigation has given rise to a constellation of theories, some grounded in observation, others still speculative, all orbiting the same question. Why do galaxies die? The black hole executioners, the center of almost every galaxy, lies a supermassive black hole, millions to billions of times the mass of the Sun. For decades, their role was thought to be passive anchors, silent giants holding galaxies together. But as evidence mounted, another picture emerged. The heart of a galaxy can also be its destroyer. When black holes feed, they erupt. Matter spirals inward, releasing titanic energy. Jets of plasma blast outward, stretching for thousands of light years. Radiation floods the galaxy. Gas, the raw material for stars, heated to millions of degrees. Once heated, it resists collapse. Clouds that should condense into new suns instead dissipate, drifting sterile through the galaxy's halo. This process is known as a GN feedback, named after active galactic nuclei. In simulations, it is devastatingly effective. Black holes can regulate growth, preventing galaxies from becoming endlessly massive. But they can also overreach, burning their hosts from within. A galaxy with an overactive core may starve itself of future light, reduced to silence by the very giant that anchors its stars. And yet, not all dead galaxies show signs of such eruptions. Some skeletons drift without evidence of recent black hole fury. Feedback may be part of the answer, but not the entire script of death. The desert of dark matter and dark energy galaxies do not exist alone. They are woven into the invisible fabric of the cosmos, the great web of dark matter. This scaffolding guides their birth, funnels gas into their arms, and shapes their growth. But the same scaffolding can betray them. Simulations suggest that galaxies at certain nodes of this web may be cut off from fresh supplies of gas. Like a river diverted, their fuel runs dry. Without inflow, star formation halts. The galaxy dies, leaving only its skeleton glowing faintly in red. But beyond dark matter looms an even greater force, dark energy. The mysterious driver of cosmic acceleration is pushing galaxies farther apart, stretching space itself. As expansion continues, the flow of matter between galaxies dwindles. Fuel lines are severed. Over trillions of years, galaxies will find themselves in increasing isolation, starved by the very expansion of the cosmos. In this vision, every galaxy's death is inevitable, written into the accelerating fabric of the universe. The violence of galactic mergers. Another theory looks not to the silent, but to the violent. Across the universe, galaxies collide. Their spirals interweave. Stars are flung into tidal tails, and black holes spiral toward one another in cataclysmic mergers. In these collisions, gas is shocked and heated, structures are destroyed. The delicate mechanisms of star formation collapse. The aftermath is often an elliptical galaxy, its gas dispersed, its potential silenced. Where two vibrant galaxies once lived, one red skeleton remains. These cosmic cannibalisms are not rare. The Milky Way itself is destined to merge with Andromeda in several billion years. What will remain may not be a spiral brimming with life, but a quiet elliptical husk, glowing red, awaiting slow decay. The harshness of cosmic environments. Some deaths are neither internal nor violent, but environmental. Within galaxy clusters, the medium between galaxies is not empty but filled with plasma heated to millions of degrees. Galaxies plunging through this medium are stripped of their gas in a process called ram pressure. Stripping. It is a suffocation. The galaxy still spins, its stars still orbit, but its lungs are gone. No more gas remains to form stars. In time, the light fades. What is left is a skeleton drifting inside the crowded graveyard of a clustered dot. Clusters thus become massive cemeteries, filled with galaxies long silenced by their surroundings. Speculative frontiers beyond these grounded theories. Speculation reaches further. Could galactic death tie into deeper laws of cosmic fate? Some physicists invoke the idea of false vacuum, decay, a catastrophic collapse of the very quantum field that underlies reality. If the universe is not in its lowest energy state, then one day it may decay into a truer vacuum. The transition would ripple outward at near light speed, destroying the structures of physics itself. In such a scenario, galactic death today could be but a shadow of a universal death to come. Others reflect on entropy, the cosmic arrow of disorder. Galaxies, in this view, are not exceptions, but participants in the universe's march toward heat death. Star formation declines, not because of isolated causes, but because entropy demands it. The universe trends toward equilibrium, toward silence. Galaxies, as temporary engines of order, cannot resist forever. And then there is the speculation of the multiverse. If our universe is but one bubble among many, perhaps galactic death reflects local rules, our version of cosmic mortality. In another universe, different physics may allow galaxies to burn eternal. Our skeletons may be the scars of our universe's specific fragility. The convergence of theories, what becomes clear is that no single theory explains all. Black holes, mergers, clusters, dark matter, dark energy, each is a fragment of the larger truth. Galactic death is not a singular story, but a chorus of endings, overlapping and interwoven. Some galaxies die by violence, others by starvation. Some collapse under the weight of their own hearts. Others fade because the universe itself withdraws their lifeblood. The skeletons drifting across the cosmos are not uniform remains, but diverse memorials, each carrying its own tale of silence. The meaning beneath the theories in the end. The theories do more than explain. They reveal a deeper truth. Death is not an exception in the cosmos. It is fundamental. Every force that builds also destroys. Every law that births light also extinguishes it. Galaxies die because the universe allows no permanence, and in this realization lies both terror and awe. For the skeleton of a galaxy is not only a corpse, it is proof that the universe evolves, that it changes, that nothing escapes the pull of time. Speculation stretches to the fate of the cosmos itself. If galaxies cannot endure, then perhaps the universe, too, cannot. One day, all light may fade. One day, every galaxy may become a skeleton, and the great web itself a monument to silence. Theories and speculations multiply, but none erase the image. Bones of galaxies adrift in the endless dark, reminders that mortality is not only human, but cosmic. If the skeletons of galaxies are riddles written in the night, then science is the patient decipherer, armed with instruments that stretch the senses far beyond the human body. To understand how galaxies live and die, humanity has built machines that can see the invisible, touch the untouchable, and listen to light older than the earth itself. These tools are more than technology. They are the eyes and ears of civilization, reaching into the darkness to uncover why the greatest structures in the universe collapse into silence. The James Webb Space Telescope, peering into origins. In December 2021, the James Webb Space Telescope, JWST, has become the crown jewel of this investigation. With its golden mirrors and infrared gaze, it looks deeper into time than any instrument before it. Where Hubble revealed the majesty of galaxies, Webb reveals their infancy, catching light that has traveled for over 13 billion years already. Webb has found galaxies that appear massive and quenched at shockingly early epochs, only a few 100 million years after the Big Bang. These discoveries are unsettling. They suggest that galaxies were able to grow rapidly, only to collapse just as swiftly. Webb's data challenges established models, hinting that quenching can occur far earlier, and perhaps more violently than once imagined. By studying the faint glow of ancient stars and the spectral fingerprints of their gas, Webb provides the autopsy reports of the earliest skeletons. Each observation narrows the mystery. Each image of a silent galaxy near cosmic dawn forces theorists to rewrite the rules of galactic evolution. Alma, listening to cold breath in the Chilean desert at 5,000 meters above sea level, the Atacama Large Millimeter Submillimeter Array. Alma listens to whispers of cold gas, the molecular hydrogen that serves as the raw material for stars, where Webb sees the light of ancient stars. Alma detects the invisible breath of galaxies. With ALMA, astronomers discovered a troubling paradox. Some quenched galaxies still contain reservoirs of gas, enough to sustain star formation for billions of years. Yet no stars are born. The ingredients remain, but the process is frozen. ALMA's findings suggest that galaxies do not always lose their gas. Instead, something prevents it from cooling, collapsing, and igniting. This points back to heating mechanisms, jets from black holes, violent shocks, or cluster environments that sterilize gas without removing it. Every measurement from ALMA is a reminder that death is not always depletion. Sometimes it is suppression. A galaxy locked in paralysis, unable to transform its wealth into new life. Chandra and XMM ghostly X-Rassatha instruments turn their eyes not to the visible or the infrared, but to the high-energy sky. The Chandra X-ray Observatory and XMM peer into halos of gas surrounding galaxies and clusters. Their vision reveals temperatures of millions of degrees, plasma so hot that it resists gravitational collapse. In galaxy clusters, Chandra has mapped cavities in the hot plasma, vast bubbles carved by black hole jets stretching tens of thousands of light-years. These cavities are scars of energy, proof that black holes are capable of injecting enough heat into their environments to keep gas sterile for billions of years. Such observations have transformed theory into evidence. They show that galaxies are not closed systems but participants in feedback cycles. Energy from a central engine can propagate outward, reshaping an entire galaxy's fate. The skeletons observed today may be the direct result of eruptions captured in these X-ray scars. Euclid and the Nancy Grace Roman telescope, mapping the skeleton the coming decade. New instruments will join the search. Euclid, launched by the European Space Agency in 2023, and the upcoming Nancy Grace Roman Space Telescope will map the structure of the cosmos with unprecedented scale. Their targets are not individual galaxies, but the scaffolding of dark matter and dark energy that defines the universe. By measuring weak gravitational lensing, the subtle warping of light by invisible mass, Euclid will chart the cosmic web, the very skeleton upon which galaxies form. Roman will complement this with deep, wide-field surveys of galaxies across time. Together, they will reveal how the environment of a galaxy, its position within filaments or voids, shapes its fate. If galaxies die because their cosmic rivers of gas are severed, then Euclid and Roman may confirm it. They may show that the deaths of galaxies are not random but structural, dictated by their place within the cosmic skeleton. Simulations, virtual universes beyond telescopes. Science has built universes of its own. Supercomputers run vast simulations, billions of particles representing dark matter, gas, and stars evolving according to the laws of physics. Projects like Illustris, EAGLE, and Tiang 50 simulate the birth and death of galaxies across billions of years. In these virtual universes, astronomers test theories, turn up the power of black hole feedback, and galaxies quench, place them in clusters, and rampressure stripping silences them. Allow cosmic filaments to starve them, and they collapse into skeletons. Yet, simulations still stumble against the complexity of reality. Observations from Webb and ALMA often outpace the models, revealing galaxies that form faster, die younger, or behave stranger than simulations predict. This gap between model and observation is the frontier proof that the true rules of galactic death remain elusive. The frontier of measurement, what science does now, is relentless. Instruments hunt across the electromagnetic spectrum. infrared to see ancient light, millimeter waves to measure cold gas, X-rays to detect hot plasma, gravitational lensing to trace dark matter. Each wavelength adds a layer to the autopsy, a different clue about the bones of collapsed galaxies. Step by step, the mystery narrows, but never closes. The frontier is to determine whether death is permanent. Could galaxies be revived? Can inflows of new gas reignite star formation in a skeleton? Some evidence suggests rejuvenation is possible. Isolated galaxies have been seen flickering back to life, forming new stars after eons of silence. Are these rare accidents, or is death less final than it seems? The tools of science are now tuned to find out. A human reflection, these machines, scattered across deserts, mountains, and space itself, are the instruments of humanity's search for truth. They embody the species' refusal to accept silence without question. The skeletons of galaxies may float across billions of light years, but human ingenuity has reached them, dissected their light, and traced their deaths. It is a profound paradox. While galaxies collapse into silence, humanity builds instruments that expand awareness. While the cosmos extinguishes light, humans forge tools to catch the last embers. Each telescope, each array, each simulation is a candle against the dark, a refusal to let the silence remain unexplored. And yet, even with all these tools, the mystery persists. The skeletons of galaxies still withhold their final secrets. We know more than we did, but less than we want. For every answer found in a spectrum or an image, new questions rise from the void. Science is not finished. It cannot be, for to leave the mystery unresolved is to leave our own fate unexamined. And so the tools will grow sharper, the simulations deeper, the gaze longer. Humanity will continue to probe the silence, listening for the truth hidden in the bones of collapsed galaxies. In the silence of a collapsed galaxy, there lingers a question older than science itself. What does it mean for something so vast, so luminous, to die? The universe has always been framed in human thought as eternal, a backdrop without end. Stars burn, yes, and fade, but galaxies immense, sprawling cities of light were once imagined as everlasting. And yet, the evidence tells another story. They too collapse, they too fade. Their bones, written in stars and dark matter, drift across the cosmic night like monuments to impermanence. This realization transforms astronomy from a study of objects into a meditation on mortality. For to witness the death of a galaxy is to confront the truth that nothing endures forever. Not stars, not galaxies, not even the universe itself. Mortality written in light every skeleton of a galaxy is a fossil record, carrying the memory of once thriving creation. Billions of stars once blazed within its arms. Nebulae once glowed with promise. Entire planetary systems may have risen and fallen beneath its light. Now, all that remains is silence, the red glow of dying suns, the absence of new beginnings. It is easy to imagine galaxies as eternal fires. They are, after all, incomprehensibly vast. But their deaths remind us that size does not grant immortality. Just as a human life flickers and fades, so too do galaxies. They live for billions of years, yet in cosmic terms, their lives are finite. They remind us that mortality is not a human condition, but a universal law. The fragility of creation, galactic death, also whispers a deeper truth. Creation is fragile. To sustain the birth of stars requires a delicate balance of forces. Too much heat and gas cannot collapse. Too much violence and structures are destroyed. Too little fuel and silence spreads. The conditions for life and light are narrow, temporary, and vulnerable. Our own Milky Way still breathes, still kindles new stars in its spiral arms. But it too is fragile. It too will merge, collapse, and eventually fade. Somewhere in its distant future, it will lie red and quiet, another skeleton drifting in the dark, and with its death, the cycle of creation in our corner of the cosmos will end. Planets that might have been born will never exist. Civilizations that might have risen will never speak. Galactic mortality is not just the loss of light, but the loss of possibilities, the extinguishing of futures unborn. The fate of the universe, the deaths of galaxies also echo on larger scales. For star formation across the cosmos has already peaked. The cosmic noon, billions of years ago, was the high tide of light. Since then, star birth has declined. Each year, the universe grows quieter, the chorus of creation fading in trillions of years. No new stars will form anywhere. The galaxies that remain will all be skeletons, glowing faintly with dying embers. The great cosmic web itself will become a graveyard, filaments of matter stretched thin, luminous no longer. The universe will become a museum of fossils, galactic bones in infinite silence, and beyond even that lies the speculation of ultimate fate. Will the cosmos expand forever into heat death, its energy spread thin until nothing moves, nothing changes? Will it collapse in a big crunch, galaxies merging into one final inferno before silence? Or will some deeper physics stark energy, false vacuums, quantum fields dictate an end more alien than imagination allows? Whatever the fate, the lesson of galactic death is clear. The universe is not static. It is not eternal light, but eternal change. And change always carries with it the certainty of endings. Humanity's place in the cemetery of lightened. Yet, within this vast theatre of mortality, humanity watches. On a small planet orbiting an ordinary star, inside a spiral galaxy still. Alive, fragile minds have built instruments capable of catching the faint glow of galaxies long dead. Against the silence of the cosmos, we have learned to listen. Against the inevitability of extinction, we have chosen to ask questions. There is something extraordinary in this. Galaxies collapse into silence, unaware of themselves, their light, fading without witness. But here, for a moment in cosmic time, a species exists that can notice, that can record, that can grieve, in a way, for the death of things billions of light years away. Humanity gives voice to the silence, meaning to the bones of collapsed galaxies. Perhaps that is our role, not to endure forever, but to bear witness, to see the universe not only in its light, but in its shadows, to find immortality not despair, but reflection. The metaphor of bones, the skeleton of a galaxy, is more than an astrophysical object. It is a metaphor written in stars. It reminds us that beauty is transient, that creation is fragile, that endings are as natural as beginnings. Bones endure when flesh is gone. They are the last structures to remain, the architecture upon which life was once built. In the same way, dark matter, halos, and fading stars remain after galaxies collapse, the skeletons of cosmic beings long past their prime. We live within a galaxy that still breathes. Its bones are hidden, its flesh still vibrant. But we know, from the remains, we observe that this too will not last. And so, every nebula we admire, every star that forms, every spiral arm that glows, is all the more precious because it is temporary. The whisper across eternity in the end, the question of galactic death, circles back to us. If galaxies can collapse, if the universe itself can fade, what then of human meaning? Does impermanence render life futile, or does it make it sacred? The skeleton of a galaxy whispers that nothing lasts forever, but it also whispers that everything matters precisely because of that truth. Light is precious because it fades. Life is meaningful because it is brief. Consciousness is extraordinary because it exists in a universe where silence is the rule. We live in the brief interval when galaxies still burn, when the night sky is still crowded with light. One day the universe will be darker, but today we see. Today we understand. Today we can trace the bones of galaxies across eternity and recognize in them the reflection of our own fragility.